Okay, perfect. So welcome to our first FoundationDB Online Meetup. We are super excited today to have Garren Smith. He's a database engineer based in South Africa, working on Tigris Data. If you have any questions, feel free to ask them as we go so that it feels more like a conversation. Garren, you are good to go.
Awesome. Great. Thanks. It's really exciting to speak here, and thanks Pia and Amir for organizing this. It's always nice to have a FoundationDB meetup. So yeah, welcome to my talk. I'm going to talk about a developer-driven approach to building secondary indexes. And I work at Tigris Data. Pia has already said my name is Garren. And yeah, let's have a look at what we're going to be talking about today. So I kind of want to look at building secondary indexes. There's some really good information around this online already. So some of that we'll cover again, and some of it, I want to look at it from different angles as well, going, there's some things that we're doing at Tigris that's a little bit more unique and different, and we'll talk about that. So we'll start out with the basics and talk about index design, how we're going to do that in FoundationDB. Then we're going to talk about index building, how we're going to build it in the background, how we're going to use a queue to do that. Then with Tigris, we have a specific schema for each collection, and we'll talk about how we'll do the schema upgrades. And finally, a few things we learned in production, not in production, in doing performance testing and stuff like that, and how we came around to fixing it. Before I continue, please ask questions. You're welcome to just ask a question in the chat. I will try to answer it straight away, or when I find the right gap, I will stop and answer it for at that time. Otherwise, please just ask a question as well. Just speak up on the mic. That's perfectly acceptable as well. So please, questions are encouraged. If you find anything wrong with my talk, please just keep that to yourself, and let's just pretend I know exactly what I'm talking about it the whole time. No, of course not. You're more than welcome to bring up ideas or issues that you found, and we can chat about them. I'm more than happy to learn about things I can do better or anything like that. So I appreciate any feedback or anything like that. Great. So a little bit about myself. I've been really fortunate to be involved in open source development for quite a while now. And if I try and mention a number, I start feeling really old. So where I've really done a lot of open source development is with the Apache CouchDB project. And I kind of cut my teeth and really learn about databases and distributed systems working on what CouchDB calls the Mango query engine, which is basically a copy of how the Mongo query syntax and stuff works. And then with CouchDB, we a couple of years back, we did an attempt to kind of rewrite CouchDB on top of FoundationDB. That didn't quite work out as well as we wanted, but then that's where I really got involved and learned about FoundationDB, and really developed a great love for working with FoundationDB, building systems on top of it, and building systems that people actually enjoy using, because FoundationDB gives you so much power to build systems that are practical, something you can reason about, and something you can work about. I've also spent time working on the Prisma ORM. That's very much a Node.js JavaScript product. The ORM is quite nice, and I did a lot of development on the Rust query engine there. So what happens with the Prisma ORM is you kind of define the query you want to do in JavaScript. It gets translated via GraphQL into a Rust engine, and that develops a whole lot of SQL queries, or it does a Mongo query and it'll do multiple queries to service the type of request. Now that was really interesting. When I'm not doing that in my spare time, I love doing rock climbing. I love taking photos, and I live in South Africa. Awesome. And so let's talk about who is Tigris Data. We are building kind of a modern open source data platform. And with that, kind of the main backbone of that is a document database that we have built on top of FoundationDB. Our document database is MongoDB compatible. And kind of one of the nice things that we've built that I think is really nice for our users is each collection is semi-structured. So you can define the types on each document that go in each collection. And along with that, we've got a full text search indexes that we support along with that. So you can do that, use that independently of the database, or use it as part of the whole database setup. Awesome. So let's kind of dive into building an index and storing it in FoundationDB. So before we do that, let's just look at what a Tigris schema is. So that's kind of the fundamental thing for Tigris, is that you can define how the documents will look in each collection. So the idea of each database in Tigris follows a very similar idea to Mongo. You have a database We allow the idea also of branching. So you can have a database and you can have different branches with different data on it. So you can do a development mode, testing mode, and your main production branch all within one database. That's all done using FoundationDB. And then inside of each database, you have a collection. And that collection is kind of a specific, you can think of it as a table in terms of SQL land. And each one has kind of semi-structured. You are allowed to have some stuff that you don't define up front, but the more that you can define up front, the better. So here's an example of a Tigris collection. We put it up here. I've written this in TypeScript, so I do apologize if you're not a big TypeScript fan, but I kind of feel it's reasonably translates to anything else. So hopefully, if you have any questions or something doesn't make sense, let me know. So we have a Tigris collection and we call it user. And we define that on top of a class. And we call the class user, and then we have a whole lot of fields. So with the ID, we define it as a primary key. We say it's a UUID, and then we say it's going to be the first order in the primary key because you can have multiple fields that make up the primary key. And this is something that would be auto-generated. And then we have name here, and we have age. And those are just top-level fields. And what we do in them is that we say index true. So that means automatically these will be indexed into the secondary indexes. We've then got a kind of embedded object. So we can define and say this is an object, and we call it location. I've left out what location looks like just to save a bit of space on the slide. Otherwise, I would be scrolling for days. But location would just be an embedded object with a couple of elements on it. And you'll see that just now it'll be clearer. And then we also have an array at the bottom. And we're saying for both of these can be indexed. So for Tigris, we can index into embedded objects, into arrays, stuff like that. So if you got a schema like that, a document will look something like this. So you got that ID we said, which would be a UID. We've got the name and the value's Garren, age 20, I wish. And then we kind of got the location. That's our embedded object, and we've got a country field, and then we kind of embedded object inside of that, and that's our home and it's our address. And then we've got our interests, which is an array of different interests: rugby, music, and climbing. So that's kind of what a document would look like. And now let's look at how we would actually index that into a secondary index and make that queryable. So first off, let's look at this is kind of the design we have for how we want to store an index in FoundationDB. So this is kind of the data structure or key format. So the first part of our thing is that we've got this index section, and that really is just the subspace. So that's just saying store indexes in their own specific subspace. There's a couple of fields I'm missing out from that, but we would have it obviously in the database subspace, and then within the database subspace, the index subspace falls under that. But the most important thing around that is we're keeping it separate from the primary data. You don't want to accidentally bleed information between the two. Then we have this key path, and I'll show you some examples of what that means, but that's just the key path of the field from JSON. Then we have version. And the version is the schema version. We'll look at that a little bit more, but that is a way of keeping track of how this field links back to the schema that's defined in Tigris. We have a value, so that's the value of the field. We have a duplicate key, that's to help us with arrays, and then we have the doc ID. So at this point, this is all on the key side, and the value side we actually keep to nil. We don't actually keep anything in the value. Later, we can start looking at keeping specific statistics or covering indexes, stuff like that. Can be something we can do later, but at this point we kind of keep it empty and we use just the key. So when you do an actual query and you get back a whole lot of rows back from FoundationDB in terms of the secondary index, you're going to get those fields, and then the most important part at that point is this doc ID. You're going to get that to be able to fetch your actual document from the primary data and finish your filtering and then return it back to the user. So that's typically how you would use a secondary index like that. Great. So let's look at that from the document we talked about before, and how would you turn that into this row of secondary indexes? So we've got the top one, which we talked about, name, and we've got our space here, our index subspace. Then we've got our key path here, which is just name. We've got 0 for version. So all of them are 0 now. We'll talk about that versioning later. And the value is Garren. And this duplicate key is 0. And then just the doc ID. Same with age, it's a top level one, so it feels pretty much the same, value 20. So now with location, you can see we kind of join the whole key path into one string. So location, we had location.country, so we join that in one string, and then we have the version again, and then we have the actual value RSA. And you can see this other one with the embedded one, we keep appending each embedded field into one long string. So we do location.home.address for a very nested object. And then we keep the value here. Then where it gets interesting in terms of the duplicate key is an array. So with an array, especially for something like a string or integers, you got a very high chance of having duplicate values. So we don't want to fail because they're duplicate values, and a user is very happy to have duplicate values. So for that, we handle that by having this duplicate key. So for the interests array, you can see here, this duplicate key is basically used to say where in the array this value's position is. So in this case, we've got interests array. We've got rugby was the first one. So we start the array counting from 0. The second one, music, and we can see the duplicate key is 1 and climbing is 2. So that what the power this gives us is that we can index directly into an array, means we can query against it. So anyone that wants to look at, say, give me specific elements in an index or in an array, does it have these fields or something like that? We can do that already because we're storing them in their secondary index. We've kind of exploded the document out and created multiple key values to be able to do that. We also store two other things. We kind of have document metadata. So we keep a Tigris created at, and that's a timestamp of when the document was created. And we have a Tigris updated at, and that's the last time the document was updated.
I have a question.
Yeah, go for it.
The previous slide.
Yeah.
If, for instance, I understand the dup key is for indexing objects in an array. But what if there is an object, an array, inside that array there is an object, and inside that object there is another array? How do you index the last array object? I mean, the fourth level array.
Yeah, that's a good question. So we did some thinking around this, and you can get, what we've decided at that point is that we don't actually index further than the first array of an object. So if you're going much deeper like that, it's just too far. You don't know how long you're going to go in. So what we actually do is create an index stub. So we say, okay, here, this field, we would stop at a certain point and say, here's the array and here's the stub of it. So that we can use those, we can narrow our search by that, fetch those fields, and then we would filter the rest in memory. So our filter in memory will be able to filter all the way inside of the array, but in the actual FoundationDB part, we've kind of stopped a little bit earlier. It's actually, I've left it out of the discussion, but we can talk about it now anyway, is that I haven't talked about string encoding. So we do ICU string encoding on the string so that they properly sorted correctly, with, like, say, if there's an umlaut or capitals or smaller or punctuation. And with the really long string, what we actually do in FoundationDB is we just actually truncate it. And so that it's not the full string, but it's a truncated version. And so when we do a filter query and we're filtering on those ones, we truncate the string again and say, give us up to that. And then we do the rest of it in memory filtering. It just makes it that the storage is a little bit more efficient in FoundationDB. Does that make sense?
Yeah, but I had another question. I don't know.
Yeah.
Why location, for example, that's a question I have. Location.home.address. I understand you do encoding, but what happens if the key inside of an object is location.home.address?
Oh, you mean in the filter, in the query?
I mean, location.home.address is the path or is the key?
That is the path to the field.
Yes, that's what I'm. But if there is a dot in a key, that scheme will break. You don't escape. You do escape the dot or not?
In the value. Oh, I see what you're saying. In the key.
Yes.
Oh yeah, but we do escape that. So that's different. So, the one is built up from actually iterating through the adjacent object and you're just kind of appending it. Those fields that are there will then be encoded to kind of be treated differently to that dot.
Okay. So, okay.
Cool.
Thanks.
Yeah, awesome. Good questions. Great. So we started that and we have this Tigris metadata. So with the Tigris metadata, what's really kind of nice is that adds a little bit of extra querying functionality. A user can kind of go, give me all the documents that were created before this time, or give me all the documents that were updated yesterday, or whatever kind of queries you want to do. We also use this updated later in building the indexes, but it's nice to kind of give the users a little bit more extra functionality in terms of querying and a little bit more knowledge of how their system is behaving. Great. So with that kind of defined, in Tigris, we do these kind of queries like this. So you kind of got a filter, and this follows very much the kind of MongoDB syntax in terms of querying. So you can kind of do a name Garren, which is the equivalent to saying, you know, name equals Garren. That's the shorthand. Or you can do range queries, age is, you know, greater than 20. Or you can do queries inside of embedded objects. So you can kind of do location.name is equal that, or interest, and there we're diving into the array and saying, find us values inside of the array. So that's how we can build out the filtering. And then what we have is kind of, at this stage, what you need is, you've got the filter and you've got the data stored in the index. You need a query planner that can actually map the two together. So the most important part is the filter. A query planner's got to go and look at this filter and go, looking at this filter, how do I build keys that I can, or a key range that I can query against FoundationDB? So with the query planner, this is something you can probably spend your whole life working on and continuously improving it. A query planner, in my view, and the little I've done on that kind of stuff, is always tricky. There's always changes and tweaks, and every time you make a tweak, you know, then certain results change, stuff like that. So for us, from a Tigris perspective, we're starting really simple, and then we're going to build it out as we go. It's kind of a big thing of getting a feel for how our users use our system, the feedback I give us, and then continuously improving the query planner based on that and based on the experience of other systems. So at the moment, it's really simple, and it looks at your filter. It looks at which keys in your filter map to secondary indexes. Once it does that, it looks at the filter and goes, do you have any secondary index keys that would be in equals? If we can, we're going to use the equals, because that in theory should give us a narrower subset of fields to query against. Otherwise, it'll use a range query. If there's multiple range queries, it will, if there's multiple range queries, it'll try and look for ones that bounded. So when I say bounded, you're going to have a greater than and less than, rather than a full range, which would be like a greater than, and then it goes right to the end of the range. So in theory, a bounded range query will be smaller. Yeah, good question, Pierre. Anyone else building query planners on top of FoundationDB?
I need a number of keys in the subspace to do that.
Yeah. So I think, Pierre, you've just nominated yourself for a talk coming up soon, query planners on top of FoundationDB.
Yeah, I think this is something that we are, when we are starting to add indexes, you know, this is like the next step. So it feels like, I feel like home.
Yeah. I think it's also one of the most fascinating sections, because there's no, from what I've seen, there's no right answer. There's always just a whole lot of trade-offs. You can do certain things to kind of give you extra things. I once met with the IBM team that works on DB2, and I mean, the way they test and experiment with query planners, I mean, they have a huge team of like, I don't know, like 50 or 60 people just working on the query planner. That's not, you know, that's not something that you got to be really careful how you move and make changes on something like that. Cool. All right. And then, you know, if the filter doesn't have any specific queries, anything that maps to a secondary index field, we fall back to a table scan. So now falling back to a table scan is also, in some sense, it's really boring, not that interesting, but in some sense, it's actually critical. It's something I learned working with CouchDB. When we first released our version of Mango, you had to define an index, otherwise the queries would just be rejected. And this, if you're an experienced developer, that makes a ton of sense, because you're like, I want the queries to be fast, I must have an index for it. But if you're a new developer and you've never used the system before, you immediately want to start querying. The filter syntax feels obvious, so you start typing in this filter, maybe whatever. If you're using TypeScript or something, it's kind of got autocomplete for you. So before you know it, you've written this complex filter and you're like, perfect, and then it just fails, and you don't know why. And so that's a big thing with the issue is that, you know, a user doesn't, you want something that a user can expect. So falling back to a table scan is one of those things that really makes it obvious to a user and kind of a little bit delightful. As they start using the system, queries just happen. They won't be the fastest initially, but if they're small data, it's going to be fast. No one's going to worry. But as they start developing and understanding the system, they're going to read the docs. They're going to learn a bit more about it. They're going to start understanding the kind of queries they're going to do. Then they can start adding indexes to make their system faster, but it doesn't feel complicated or overwhelming in the beginning. They can kind of learn little bits as they tick along. So that's a good thing. Yeah, 5-second limit on the table scan. What we're doing is, we will stick to the 5-second limit on FoundationDB. So if you're not familiar, FoundationDB, each transaction, so when you're reading or writing, can only last for 5 seconds. After that, the transaction will fail. So with our stuff with the table scan, we'll keep it to 5 seconds initially. If you want to go across 5 seconds, you want to go longer, so that means we will reopen a transaction, start a new one, and continue streaming the results. That has to be an opt-in, so you have to kind of specify it in the parameters. The reason we specify it in the parameters is that it's an advanced feature. You kind of have to know what you're doing. If you're exceeding 5 seconds, you kind of have to realize that you could get duplicate results. You're going across snapshots. So this is something you need to opt in and kind of be a little bit aware of what you're doing. Great. So one of the things I toyed with in the beginning, and I still kind of go back and forth on it, is should we just auto-index every field in the document? So a document comes in, just auto-index it all straight away, and then a user never has to worry about adding indexes and stuff like that. I go back and forth on this, but the big thing with this is that it immediately makes it that queries work really well, because you automatically, whenever you do a query, we've got a secondary index that covers whatever you want to do, and we can do quite an efficient query. So it works great for large databases. But then we started testing this started doing some performance testing this, and it wasn't particularly fancy documents. They were probably like a 1 kilobit size, and we're just kind of hammering the system. And we immediately noted there was the writes were slower, not hugely, but enough that you would notice and go, oh, that write is a little bit slower. And you're like, oh, wait a minute, that's interesting. It's a little bit slower because it's indexing the whole document, which obviously is, to me and the team when we were doing this, you're like, yeah, but cool. It's like, you're like, oh, it's not so bad. Like it's only a little bit slower, it's only like another 15% slower. That's not a big deal. And we're like, oh, we're super proud of the system. But then we took a moment and we kind of stepped back and said, wait a minute, if you're new to the system and you start writing to the database and you start going, oh, wait, this write is a little bit slower than I would expect a database like this to be, that's very disappointing. I'm going to move on. And then you're like, oh, well, wait, because they're not likely to know that we're indexing everything, and they probably don't want all those fields indexed straight away. So it kind of in the end felt like, oh, you get this advantage of when you read, you're going to get slightly faster reads, possibly, or hopefully, depending on how you're using the system, but your writes would be a little bit slower. So we kind of go, wait, this isn't ideal. And so we kind of looked and go, well, you know what? Most experienced developers are used to adding indexes. So let's make it intuitive to how they've used other systems. It's kind of like that thing of whenever you use something like Word or Excel, if it's completely different from what you're used to with Excel, it feels super weird. So we thought, well, we'll follow that kind of design with indexes as well. As I mentioned, a performance decrease in writes without the developer knowing why, that feels a little bit weird. But then we thought, well, we're going to definitely revisit this later and maybe add some extra helpful options. Maybe when you define the schema, we're going to look at adding like you can add another field and go smart indexes or something like that, where you index specific fields or top level or something like that. But it's definitely something we can play around with, in terms of how you make indexing intuitive to users, because it's that balance between an experienced dev who wants to be able to manually control everything to a new developer who's never used the system before, who just wants to build a little web app or, and something like that, and they want it just to work perfectly in the beginning. So yeah, something interesting to always think about. Great. So we've kind of just want to check if there's any questions at this point. Cool. All right, I'll keep on going. So now we've kind of defined the structure, how we store in FoundationDB. We can filter it and query it. Now, how do we build the index? Because there's kind of two parts to that. So the first one is that documents, the moment you've updated your schema and said, I want this field indexed, any document coming in after that will be indexed in the same transaction that the document is stored. That's just the beauty of using FoundationDB, is that you immediately get these nice, your indexes are consistent with your primary data. So every time the document comes in, we index it at that point, store the keys in the secondary index, and we store the primary document. But now if you've had this database for a long time and you've stored a lot of data, you're going to have a whole lot of documents beforehand which haven't indexed that field. And that's where we need to build that index in the background. And that's kind of the part we're going to cover now. How do you do that kind of background indexing? So the first thing with background indexes is you're going to have some kind of background queue system, and you're going to have some workers in the background that sit there and go, okay, this index needs to be indexed. This document, this collection has a new index, and we've got a whole lot of documents we need to run through, and we need to add them to the secondary index. And that's typically how you want to do it, but there's some little tricks around it. So the first thing I'm going to say is that half the work I felt was marginally done for me, because the Apple team had written a really nice paper called the Quick Paper, and I can send links so that we can have it in the meetup later. And they kind of talked about how to build a queue system using FoundationDB. And I read it and really liked it. I've been involved in a bit of queue. We built a queue for CouchDB on top of FoundationDB, and that felt pretty good as well. But this one feels a little bit more intuitive and really simple, which is always, whenever you say something's like, oh, it's really simple, you're like, oh, that must have been easy. But you can see it took a lot of time and a fair amount of thought to actually do it. The paper is quite approachable and quite readable, for academic papers. So it's definitely, if you've got some time, I would really recommend reading it. So we've taken some of the ideas. We haven't copied it verbatim. We've taken some of the ideas, fitted to how our system works. Pierre, thank you. Perfect link to the paper there in the chat. Give that a read. The most important part of when you're indexing is you need to index up to a watermark. So you need to kind of say, index all these old documents up to a certain point. If you don't have that watermark, what happens is that it's going to just be unbounded. If you're going to just keep indexing as writes are coming in, so for some reason, maybe you're not indexing in the same transaction, you can get into situations with a database with high writes where you just never catch up, and that index is never actually going to be ready to be used. And finally, kind of a bit of a caveat. Everything I'm talking about now is very much a work in progress from our side. This is the kind of the final parts of our indexes that we haven't finished. And so some of this has been implemented. Not all of it's been properly tested. We could easily change it as we go along. So if you spot anything that I'm missing now, you can probably save me hours of debugging. So please let me know. Let's dive into it. So let's look at the queue design. So this is how we want to store a queue, or the data structure we'll store in FoundationDB. So we have this queue subspace, and that again is like the index subspace, just a separate place for us. So this is where we deviate from the Quick Paper with the CloudKit queue. They kind of keep a queue in each tenant or each database for each user. And then that can be replicated across different clusters, stuff like that. And then they have a higher global queue that they then use to kind of indicate that certain databases need work done, or at least that's how I interpret it. For us at this point, we don't need something that's as complicated as that. So we've kept it much simpler and have just one global queue for now. As the system grows, we can then split it up into that kind of design as well. So we have this queue subspace, which is where all the work that needs to be done. We have this vesting time, and that's kind of the most critical thing around how the system works. And the vesting time means that everything is actually ordered by time, which is kind of a thing that makes me feel super weird a little bit thinking about distributed systems and time. But it's also, the exact accuracy of the time is not critical. The main use of the timing is that we order the queue via this vesting time, but whenever a worker asks for items in the queue, it can never find items. The queue API or queue system will never return items to the worker that are stored further than the current war clock time. And we'll dive into that now. So I'll show you that in a little demo what that means. Priority, it just means you can set the priority on certain items. So 0 priority is the highest priority, and you can go down as far as you want to do. We have an item ID just to be able to identify the item. And we have a job. And that job is your kind of the way you define what kind of work it is. For our case, in this time, it will be a job describing the index that we want to build. So it'll be the database, the collection, any information that job will need to be able to build that index. So as I said, vesting time, that's the wall clock time when the item is visible to background workers. And so let's look at what that means. So let's pretend this is data stored in FoundationDB and this is our queue. This first value here is our vesting time, and it's just a Unix timestamp, a very bad one in my case here, but just to example it. So we've got 1, 2, 3, 4, 5 jobs sitting in the queue, and we've got the earliest time is this one, the latest time is this. If our current time maps to ID2 here, so it means this current time is the same as this one here. Whenever a worker asks the queue API and say, give me, can I have a look into the data, into your queue system? Can I peek inside of it and say, give me any workers that are available? The queue API will never return anything later than that. So ID 3, 4, and 5 will just sit there and they'll not be visible to workers. Once the time changes to this, then it will be visible. So what this means then is when this item ID1 is visible to the users, to the workers, a worker will take this item and say, okay, I want to work on it. And it'll go, okay, look, it's building an index. And we might have it, at that point, we're going to have an encode, set time and go, an index, a background worker will typically take 1 minute to work on indexing. So what it'll do is it'll open up a transaction, take this item, and then it'll actually let the queue API know that it wants to obtain a lease on this and say, I want to work on this item. And it's going to set it a delay time and say, I'm going to work on this for 1 minute. So when it says that, what happens is that item goes from the top of the queue to the back of the queue because its time has been incremented. So it's been pushed back to the queue here. And it means that because the current time's here, no other worker can see it. So it's going to be pushed far enough down that no worker will see it. And what's really nice about that is that you're not losing the item, because the most critical thing is when you take something off the queue, you don't want it to get lost. If the worker dies or the pod gets restarted, you don't want this job to disappear without being completed. So this way, we're taking it off, we're adjusting the time and putting it back in the queue, all in one transaction. So if that's successful, we know we can work on it. If the item dies and if the worker dies and doesn't finish this work, at a certain point, this current time is going to equal this back of the queue time, and a new worker can pick up this job and continue working on it. That to me feels really intuitive and really kind of a straightforward way of doing it. You typically, in other designs, you kind of put it on one queue, which is the working queue, then you have the active queue, and then you've got something that has to keep monitoring these two to make sure that anything that's in the active queue or something like that is, hasn't died, and then you have to put it back in the other queue. So there's no movement of anything. It's just one linear path of things you're working on. Obviously, as a worker is working on something, they can continuously bump this further and further down the queue so that it makes sure that no worker gets to it. And that's their way of signaling that they're still working on it. Let's look at the API, and then I'll take questions after that. So if anyone's kind of puzzled or anything like that, we can chat about it further. So these are the kind of 5 main API things you need. So the first one is in queue. So the moment we hear that an index needs to be built, we enqueue it in, and we say the delay time. So this delay time is basically say, I want the workers to start on immediately, or I only want them to start working at it in a couple of minutes time or a couple of seconds time. That's just an optional kind of delay. Peak is kind of the one that's most critical. This is what a worker goes, I want to peek into the system and give me a max number of items. And it can then choose from those items which one it wants to work on. And this peak is the one that will never exceed the current wall clock time. Then once a worker has an item to work on, it's going to do this obtain lease. And it's going to say, I want to work on this item. And that's its lease time. And say, I want to manage this. I want to have the lease time of this thing for an X amount of time. And then as it's working on it, it can continuously renew that lease. So maybe it's going to do a batch, fetch an X number of documents from the FoundationDB, work on them, and then say, okay, I've done that one, I'm going to renew the lease. And then finally, when the item is finished and it's completed, it'll mark it as complete. That item can now officially be moved off the queue or move to a completed section if you want to keep a kind of a queue history. Does that make sense?
Yes, it makes sense. There's a question by Pierre.
Yeah. You cannot choose priority. Yeah, you would. I've kind of left priority out of this API here, but you could definitely set the priority in the API. So you could either go, maybe, background at this point, switch background indexing to priority 0 and everything else to 1 or something like that, for sure.
I have a question. For example, you pick some items in the queue. So you fetch some items that are supposed to be ready to be processed.
Yeah.
So my question is, if you have several workers, what happens?
Yeah, it's a good question. Because if you all pick at the same time, you're going to possibly get collisions, and that's kind of where you need to peak. When you do a peak, and you know what, I realize I've misspelled peak again. I always spell it EA, so I do apologize. Now it's recorded into YouTube, so known forever that I am a terrible speller. So the big thing is that with peak, you want to pick a couple items, so 5 or 10, and then you're going to randomly choose one of those in that, just to reduce the chance that you're going to collide with the other items. That's one way to handle it. Otherwise, what you're going to do is that you just pick the first one. If it collides, you're going to just peek again, find another one, start a new transaction, peek again, because the one worker would have grabbed it, you would then grab it again.
Okay, that's not how I do it. But...
Okay, yeah, how would you do it?
Well, I'm not sure what is lease? I don't understand. I don't know this word.
Which word?
Lease. The second obtain lease, renew lease.
Lease.
Yeah. Lease.
So that lease is basically saying you're going to say at this point, I want to work on this item. So you're going to peek. Yeah.
That's what it's a two-step process. What I do is I pick some items. Then yes, I didn't use random, but it's a good idea to pick among the items that I selected which one to work with, and then I try to obtain the lease for the item I want to work with, and the obtain lease, I guess it is returning a boolean that's saying yes, you have the lease or you don't have the lease, something like that. Or otherwise, I don't see how this can work.
Yeah. Sorry. Okay. So no, you're dead right, and let's. That I actually cover that in the next slide. You're absolutely right. So that's exactly what we're going to do is you peek, you get an item, and then you automatically make that call into obtain lease to say, I want to work on this item. So then that means that you're going to create a conflict if someone else tries to do it. Excuse me. Or the system will warn you that another system and that something else has tried to obtain a lease on that already. So if we look, let's look through an example of a background worker, and then you can tell me if that's kind of, if you agree with that, or if I'm still missing something there. So the system comes in and you get a schema change. And so a collection gets a schema change and there's a new field that needs to be indexed. That's automatically, that index job is added to the queue. And we have a whole lot of metadata around our index that we store. So, and in that metadata, we're going to say this index is now write only. So don't start issuing queries against it, but we have this index and it's in write only mode at this point. Okay. So this worker peaks. So one of the workers is in there, it's idle. It does a peak, and I've misspelled peak again. Does a peak and it gets an index job and it says, okay, cool. I can start working on this item. It will then obtain the lease and say, I'm working on this. And when it does obtain lease, that's when it says how long it's going to work on it. So it says obtain lease. That's going to push it much further down the queue again and not make it visible or accessible to any other workers. It's then going to start working. And it's going to do, say, a batch fetch of a certain number of items from FoundationDB. So it's going to say, fetch me 20 documents. Okay, so what I haven't done here, well, kind of talked about here, is we're going to batch fetch the items from FoundationDB up to the current time. So part of the index job is when we add it in, we say, this is the current wall clock time. So now this isn't 100% accurate, but it gives us a base kind of watermark line to go, this is the current time. Now we're going to use that. We talked about that index that we have, that metadata where we do Tigris updated at, and we're going to use that. And we say, start at the earliest time we can find in that updated at, which is, the earliest will be null. So find us anything that hasn't been updated before and start querying up and fetches all the documents up till it matches this time. That's the wall clock time when this index was created. Obviously, when we get to this wall clock time here, this time is a little bit shady because now, each different pod's going to have a slightly different time. So you're not going to be 100% accurate. So when you're reaching close to that point, we now need to be more cautious. We're going to actually have to get the last couple documents and confirm that they actually have been indexed already. But all the ones before that, we can read in batches. So we'll read a few of them, read a whole batch, say 20 or 50. We'll index all of them in a transaction. Once we've indexed them in the transaction, we'll then update the, we'll do that API here. Let's see if we can go backwards. We'll call this renew lease to say, we're still working on this, push this further down the queue so that no worker takes over this. So we're still ticking along happily and we're working on this. So it does that. And it's going to keep fetching items, keeps processing them, it'll process those items, index them, and renew the lease again. And it'll keep doing this. So, keep batch fetching, keep renewing the lease so that it can keep building the system. No worker can take over it, and it's indexing along. At a certain point, it's reached up to the updated time. We've checked and validated that those documents are all indexed as well. And the worker is confident that the index is up to date. It's going to then mark the queue item job as complete. And we're going to update the index metadata to say the index is ready and it can now be queried. And it means the moment that transaction commits, any query coming in after that can immediately start using that index for any queries. Cool. Any questions on that?
Yes, I have a question. When the second bullet to mark index as write only,
yeah,
that means that incoming insert will write into the index.
Yes.
So so there's basically two sides. The incoming insert add new items to the index, and the background worker will basically populate the index with all the records.
Correct.
Okay.
Yeah. Awesome.
Yes, there is a missing. It's an elliptic, but if the worker dies between the 5 and the 6, between the 5 and the 7, sorry, in the API, there is no way to say, no, it's this time. Okay, I got it. Sorry.
Yeah, so I don't have a perfect answer for this at this point. And as Pierre, as you said, using the created at modified. Yeah. So to answer Pierre, yeah, we're going to index that, create that, and modify that. So we have that information, so we can use that to build the index. So we can kind of have a rough idea of when to stop. It's not perfect, but I think it should do what we need to do. I'm used to kind of CouchDB where we keep a changes feed, which is really nice because with that, you can kind of run through your changes feed and see all your documents and then automatically index that. So that's quite like a lot more straightforward than using this timestamp. But yeah, so what we would probably do is as you batch fetching, in the same transaction, once you've completed and once you're renewing this lease, what we would also do is update the index metadata to say, okay, we've indexed up to this key over here, so that if this worker dies, once it's committed and it dies in the next transaction, any worker that picks up from that point can actually look at that metadata and say, okay, I only need to continue from that point.
Okay, I got it. It's an error case, but well. Okay.
Yeah, I mean, but an error case was definitely going to happen. I mean, you can just suddenly do a new deployment without letting anyone know, and you just restart indexes and they're halfway through. Yeah. That's definitely going to happen, and you have to be able to recover from that. Awesome. Okay, so what we're going to do now is let's look at schema upgrades, because this is something that's quite interesting as well and a little bit different. So as I mentioned with with Tigris, you can define a schema. So the first two cases are quite straightforward. If someone has a schema and then they change it, and if they remove a field, so if there was a field that was previously indexed and they now no longer want it in their schema, they're going to remove it from their schema, and then it's reasonably straightforward. You put a job on the back of the queue and say, delete this index. It's no longer used. That's quite straightforward. The other one is basically what we've talked about now, is if there's a new field on this in the schema, or an existing one has been changed to say we want this one indexed, we will do what we've done now. We add it onto the queue and we will build it in the background. But now there's the third case is where there's a change of field type. So you might have an index on a specific field already, but they've maybe the user originally used it as a string, and now they actually want those fields to be integers. So what the Tigris does for the primary data, if you have a document and you've stored one field as a string and now you've converted it to an integer, you actually want it to be an integer. When we read that data back from FoundationDB, we will try to do an in-memory conversion. So if that string is a value, it is a number, we'll convert it into a number and return it as expected as a number. If we can't, we will return, we will give back an error with that document to let you know that that's not possible. And we have a whole lot of rules and checks around this when you try and do this and upload a schema, whether we can actually do that kind of conversion. But now let's look at how we handle it in the secondary data. So if you look at it, here's an example. We've got our index layout in FoundationDB, and this is how the data was stored initially. We had this age, and the user was storing it as a string instead of a number. So we'll keep it like that. So that's still in the database. But now they started updating and adding new documents, and those are now stored as an actual number. So we've got it here as 20. So when a query comes in and we're going to use this specific field for indexing, we have to actually break that query into two separate queries. The first query is we'll use the latest version. So we talked about this version, and that's the schema version. So we'll use that one to say, give us all of the fields of the latest schema version, in this case, schema version 1, and we'll return those. So we'll start at this one and we'll read all of those ones, and we'll do the filtering, in-memory filtering, and return those documents to the user. After that, we have to do a second query and we go, give us all the older schema versions. So this case, it's this one here. And this is a 20, but now it's a string. So we'll do a query on all those. We'll fetch the primary documents. So the documents, we'll convert that field into a number again and run it through the filtering and make sure that it actually passes the filter, and then we return that to the user. So the downside of this design is that you won't always get your results perfectly sorted. If you had, some values that were lower than the values returned in the schema version 1, they're going to be slightly out of order. But the advantage of this is that for a user, they're still going to get all their values exactly in the type they expected. They always get them as a number because we can run through different ones and convert them. At the same time, while we've done once we've noticed the schema change, we are going to have a background worker that will have to run through the secondary index, find all the old documents, and convert them to the new schema type. So that will happen in the background. And eventually we will reach parity where we don't have to do multiple queries. We can just do the single query because everything is the type we're expecting. Cool. Awesome. Yeah, let's look a little bit at like index statistics and hotspots. Shout out to Alex who's in here. He helped me a bit with this as well, so that's really cool. So one of the things we wanted to do was keep a bunch of metadata around the index. We wanted to have a whole lot of kind of index metadata, and the idea was that we would update this via atomic updates. So we would keep and the reason we want to use atomic updates obviously is that that's going to avoid any write conflicts, because if you're doing lots of indexing and you run to the same field, you don't want to have lots of transactions run in the same field. You're going to get conflicts. So using atomic updates means that you automatically avoid that situation. So you can avoid those write conflicts. But then we discovered something else. So first off, I'll just show you how we actually wanted to design it in FoundationDB. So we wanted to have this metadata where we keep a count, so we know the total number of rows for an index. We also wanted to have something that was like a size, so we could work out how big is this index. This is especially useful for things like billing, stuff like that. And then we also wanted to have a path count so that we could dive down into certain levels of the index and keep a count of the number of rows. The idea there was to use that for our query planner. So if we had a filter with multiple options in terms of secondary index, we could kind of read this path count and go, oh, look, this index has less rows than this one. We're definitely going to use that one instead. So that was working really well. But, and in theory, and as usual on my laptop, this works great. But we started running a whole lot of performance tests on this, and especially in writes, as we were writing into the database, we immediately saw that the atomic updates that we were doing was significantly higher than any of the other number of writes we're having to do. And the big issue here is that, you know, there's no conflicts. All the writes are happening, everything's working, but because there's so much atomic updates happening to single specific keys, it was slowing down the transactions because these all have to kind of be queued up and batch, you know, all individually applied to those specific rows. So this led to our indexing being significantly slower than what we wanted it to be, which is an interesting, slightly frustrating thing. So this led to a much slower kind of throughput. But it was also an excellent reminder that you always got to be performance testing. You know, the closer you can get to kind of production workload, the better. But even start out simply from Tigris's side, we have got Go YCSB working, and we can emulate specific types of documents and do a whole bunch of testing like that to kind of go, how will the behavior of the system work? Also, a shout out to tracing and metrics. It always feels obvious that you should have lots of metrics and tracing, but when you start reaching bottlenecks and stuff like that, it's really helpful to have that kind of information. We use Datadog, and that gives us some really great insight into the system and tells us, you know, what kind of FoundationDB transactions or operations are happening, which ones are happening the slowest, stuff like that. And that makes a big difference when you're building a database to actually understand what's happening underneath and what's the behavior like at certain different loads. Yeah, super awesome. So what we've done is we've replaced it with the API get estimated range size in bytes. I didn't actually know about this one until recently, so it's a pretty cool functionality. And so what this does, obviously it says it in the name, but it is an estimated, so it'll give you an estimated size from the docs that I can read. You know, if your index or the row you're reading is quite small, it's not going to be very accurate. But if you get kind of over 3 megs in size, then you're starting to get an actual accurate range because it's kind of doing sampling in the background. And that's perfectly good enough for what we needed to use. We'll experiment with it a bit more. It'll be really nice to kind of see if you can use that estimated range size to say, all right, we're going to do a query with these 2 different filters. Let's get an estimated range size on those 2 sides, 2 ranges, and see which one kind of gives you a smaller value. Could we use that one instead? I don't know if that's possible yet, but it definitely could be interesting if we could. So yeah, so that's kind of something we learned, performance testing. And yeah, for future work, these are the things we're going to be working on next as we build it out. Unique indexes is a nice thing to have for a user. And with that kind of data structure we have in FoundationDB, you know, we can modify it slightly and then you can immediately make it a unique ID. So you can take out the doc ID that we have at the end of the field with a duplicate count, we can remove that. And then you've got a unique index design. So that's something we want to work on. We want more complex filtering. At the moment, some of the nested fielding and stuff like that, we don't have as many options as, say, MongoDB supports, and that's something we're building out at the moment. And then the kind of eternal thing that never really stops is kind of a smarter query planner, and kind of build that out more and more as we work on it. Up here, your estimated size is computed with keys and values. Yes, but with secondary indexes, we have no values. So it's just the key size. Cool. Yeah. Thanks for coming to this. Thanks for listening. Thanks for the great questions. You can find us on GitHub over here. You know, we've got the whole code. It's fully open source. You can take a look in. If you like Go programming, it's all in Go. Quite a big fan of Go nowadays. You can sign up for the beta or join the Discord community. So you can visit our website there. We have a cool Discord community that you're more than welcome to join. If you suddenly at the end of this meeting have realized there was a question that you forgot to ask me, please join the Discord community. The whole team's there. We're happy to answer them. Happy for you to try the system out, play around with it. Would really appreciate all your feedback, stuff like that. And yeah. Thank you. Any questions, you can find me, Garren Smith, on Twitter or in the Tigris Discord community. Thank you.
Thank you, Garren. Is there any questions? I have many questions, but maybe there are others. I mean, we will stop the record once the questions are over. Is there any questions before I'm firing mine?
I have questions about the path thing, the path. What's the name of the variable? The path. Can we go to the first slide that introduces the path, please, with the index thing? With the path.
Yeah.
Or any slide with the that describe the key of the index. Yes, that's the one. I think the first thing that, like I said, the dot must be escaped. But then there is also, instead of escaping the dot, I'm wondering why you don't use nested tuple in this location. The second, like location, home address could be a tuple.
Yeah, I mean, you totally can. This isn't, I think this is very much your kind of choice in your design. We played around with both, and then we kind of felt, this was working for us. We've used a similar design in search, and we haven't had any issues with it. So we were confident that it'll work.
Okay, and there's once basically yes, so it doesn't work. You don't like the approach of using a tuple, but if you use a tuple, then it becomes easier. You don't have type problems with the path, etc. You can introduce like the tuples items are only strings, and when a key's value is an array, you can use a specific value to say at this point in the path in the documents that is an array. You don't use the index at all, and afterwards during query you check in the document that it's the correct index, because that way you don't have to use the column where there is the column before doc ID. But I don't understand why you store basically the index of arrays of the first array. I don't see the point.
Sorry, I think I've misunderstood you. So this is a tuple here. So this is definitely a tuple. It's just that we don't keep the path as a tuple here.
Yeah, I think it's better to use a tuple. But look at the last three lines.
Yeah.
I don't understand why you store 0, 0, 1, 2. The last the
Okay. So that's for the duplicate key. So that means that if this was also rugby, so if someone had an array which had rugby, climbing, you need that duplicate key so that these are all stored separately, and then you don't kind of create a collection.
Yes, okay, I got it. Cool. Because yes, you're right. You need to have that to
because people do weird. Users do weird stuff with documents, so you got to try and think of as the weirdest thing someone's going to do and see if it'll work.
Yeah. I don't think I have another question, but my comment about the Tigris data, basically what you are doing, I think following MongoDB path is good for business because there is a lot of MongoDB deployments. But I'd rather avoid working with MongoDB myself. I mean, the MongoDB API.
So maybe that's something I didn't specify well enough. You're right. We do have MongoDB compatibility because a lot of users are used to that and familiar with it, but we also have our own API. So if you look, if you're familiar with Go or TypeScript or Java, we have our own actual client that you can use. So it doesn't follow the exact Mongo API, it uses its own API. So, take a look at our docs there. That's kind of our big thing at the moment. And the MongoDB compatibility we're going to be announcing quite soon. It's there already. If you read our blog post, you can use it. But there's also our own API that I actually really like. I mean, defining the schema and stuff like that feels really natural to me, but it's also difficult for users when you're not having to learn a new database, a new design, then it's, sometimes easier just to use an API they're familiar with.
Yeah, sure.
What do you mean by compatibility, protocol compatible or SDK compatible? Both. So we will have, you can use Bison, the wire protocol will support the wire pro. So you can basically, with Tigris, you can just basically have if you're using a MongoDB driver, you just you continue with your MongoDB driver and you just point it at Tigris instead of Mongo and it'll just start working.
Yeah, right. So you are implementing like the old MongoDB version, the 4.0 something because of the license?
We're doing from 6 upwards, I think, but it's just the protocol. Yeah. Whatever's legally allowed to do. We're not actually hosting the database.
Yeah, right. Okay.
Yeah.
Any other questions?
Yes, I have a question. I don't understand what is the query planner. What is the problem with the query planner? I don't understand because I wrote query planners, but what I do is that I keep the query semantic simple, so the query planner is trivial.
Yeah.
Obviously, if you write a query,
so I mean, okay,
that are super complicated, you end up with a query planner that is.
Yeah. I mean, I think in some sense a query planner is simple, and sometimes it can get it. It kind of grows with its complexity. One that feels simple but is so confusing is, what do you do with an OR? Like if you've got a query with an OR, how do you know what to do with it?
Depends on the OR, but you do you spawn several depends. Yes, you spawn several Go routines and you query every index separately and you merge them later.
Yeah, exactly. But is that the best time? Should you do that every time? Do you reject it? Do you just, is maybe a table scan even better than doing that sometimes? How do you know?
Yes, that's a problem about the table scan.
So that's kind of
between
that's the thing with
table scan is complicated.
Yeah, but that's the thing.
I didn't think about that. Thanks.
Yeah.
Because I always use the index. That's the problem I have. So now I understand better.
You see, that's the hard part. The hard part is if you know how the system works and if you understand indexes, you can write your queries to your index, and that's very good programming. That's makes your life easier and it makes it easy to reason about it. But when I worked at Prisma, a lot of our users were beginners, and it was fascinating because the Prisma API for someone, I don't know if you ever used Prisma, but the Prisma API for a beginner is so intuitive. It's so easy for you to get started. It's easy to build a filter, and it's got really nice kind of autocomplete. So as you start typing, even in TypeScript and JavaScript, it starts telling you, oh, you want to do a where, and you want to do where on this field that does this, and it does, what about this field? And it can help you. And the users write these long nested queries they're super long, 4 or 5 layers with ands and ors, and it'll have a not with ands inside of that and maybe another or, because they're just kind of reasoning in their head. But then at a certain point, they just keep typing till they can't type anymore. Basically they don't know what they're doing, but they just keep typing and they keep running the query and seeing if they get the result back or not. So it's not a logical query and it's not a good query, but it'll work. Especially if you've got 5 rows in a table, it's always going to work and it's going to feel fast. And that's where a query planner needs to come in sometimes. I mean, if you look at like Postgres, like people do inquiries that are huge, like you'll send through, 70,000 IDs in an inquiry, and Postgres can handle that pretty well, which is insane. Like that scares me. But it can do that. Query planner is smart enough to handle those kind of situations. And that's really fascinating, but yeah.
Pierre asked a question in the chat.
At this point, I think we will probably just build our own. But I'm definitely, I've done a little bit of reading around what's it? Apache Arrow and Data Fusion. Is it Data Fusion or Apache Arrow?
Yeah.
They've got some cool stuff there. One of the developers wrote a really basic, like it's a very basic book, but it's really helpful around how to build a query engine. So I'd love to take some inspiration from that. You know,
we have a branch on our side which is using Data Fusion.
Very nice. Okay, cool.
So yeah, this is why I was asking if you are reusing something, because it's like huge work to implement a query planner and query engine. And it's always interesting to see if you can just use something like Data Fusion or Apache Calcite or something like that to just, you know, plug your storage and let the query engine works.
Yeah, for sure. I don't have a perfect solution, but it's definitely something we need to kind of investigate a bit more.
Yeah. Any last questions?
Yeah, about the query planner engine, there is Data Fusion and what? I'd like to know more about this stuff. It seems like I'm missing something.
Yeah. There is Data Fusion, which is in Rust, and there is Apache. That's Calcite, right? That's Apache Calcite, which is something that you can reuse, but it's in Java. It's JVM, but is it Java or? I think it's Java.
Are you looking for query planners or execution engines?
That's a good question.
I guess both. I'm not sure what is the difference.
So there's different sets of projects for if you're looking to have a query and have that query turned into a like physical plan. So basically that is the optimization steps of you know, simplifying your predicates and filters down to and removing like logical equivalences of being able to apply rules like when do I apply the filters, what order do I do joins in, and then turn that into some physical description that is sort of the exact data flow graph that should be run for that query. And then there are separate sets of projects which consume some description of a data flow graph and then have all of the optimized implementation of that. So it's on that side that you'd actually be able to like run the thing and they like have a filter, but their filter is implemented and you have like the SIMD optimized filter. And then for join, they have all the implementations and they implement like, oh, we can do a hash join, but then hash join that understands that your data might be skewed and has an optimization to handle skewed data. And then it might be too large, so you might have to spill to disk and like has all of that implementation behind it. And it's the current wave of stuff has been that those are kind of split in half. I think Apache Calcite is probably the most well-known query planning project that's relatively reusable. And then Data Fusion and Facebook released Velox, VELOX, are probably like the two query execution engines that are the most well-known. But I'm assuming reusing these things is also going to be an own adventure if you aren't already in like their exact sort of schema catalog DDL world.
Yeah, I think that's the problem, is getting that there's a bit of a mismatch between the two.
What do you mean a mismatch?
Well, I mean, you're storing data in a document database, and then you're trying to get that to work in Calcite, which is maybe expecting a SQL table, stuff like that. So it's trying to get the two to work together.
Yeah, you're right.
I have another question that is not necessarily about Tigris Data, but you can answer, Garren. Also, because you use FoundationDB, what is the point of having several clusters in production? Why not use a single cluster, possibly with several tenants, the new API in 7.x, and call it a day?
I'm going to leave someone else to answer that.
But people say they have several clusters in production. That's why I'm asking. I'm surprised about that.
Is that not for different regions? So, I mean, like you'll have one cluster that serves all the traffic for EU, and you'll have another cluster that serves traffic for, you know, US North, US West, and US East there.
Maybe.
I think.
Well, yeah.
Typically, I mean, that's how we plan to do it. Well, that's how we do it. You know, we have different regions, and then, you know, if you got your database, if you got your app sitting in Europe, and then you got your database sitting in US West, US Pacific, is that what you call it? What do you call it? Pacific. Then, you know, that's quite a latency.
Yeah. Now it looks like our Datadog person left already, which is a bit unfortunate because I think they were possibly one of the cases that I'd heard of that was running many small clusters.
Okay. And was that, I mean, I don't know how much you know, was that many small clusters with data shared across those clusters, or each data in each cluster is separated?
It sounded like they're, I mean, I would assume then that their like data model is somehow very partitioned such that having it across multiple clusters doesn't matter. And for them, it was sort of like failure domain isolation, something I thought. But no, I guess we're still recording and I have no memory of where I got this information from. So that also could be some totally different user that I spoke to like 3 years ago or something.
Yeah. Alex, I got a question for you. That get estimated range size, how much can you trust it and use it?
In practice, it's like pretty reasonable.
Okay.
I think if you look at it from like a mathematics perspective, it's probably it's probably weird. There's probably some theoretical pathological workloads that will completely fool it.
Yeah.
But everything that's sort of off of like how FDB's internal data distribution understands what like the size of different data ranges is and how it makes splitting decisions is all kind of based off of that data. So if there was anything that was relatively egregiously wrong with it, there's a decent chance it would have been found sometime over the past 10 years.
Okay. Oh, that's good news. So it's not just something for the users, actually used internally. That's kind of a nice thing to know.
Yes. So so this comes out of the FDB byte sample, which is basically like looking at the stream of mutations that come in and then taking the length, like the number of bytes in a mutation gives you sort of the probability of it being inserted into the sample. And then clears are applied to the same data structure. So it's sort of like taking, you know, 1 out of every 1,000 mutations of yours, but 1 out of every 1,000 where it's weighted based on the size of that mutation, and then maintaining like a much smaller version of your data structure of that. And like, you don't need to store the value, then you only need to store the key, and then just like sort of how many bytes were associated with that. And it gives you a way that you get kind of like a probabilistic sketch of the distribution of data within that like subspace or shard. So that if you want to ask like, hey, where's the midpoint? Then you have a very quick way to sort of look up in this byte sample, like where the midpoint of it likely is, or like, you know, where's 30% of my data. But it also then gives you a way that you can just sort of do a range query across this and count the number of sampled bytes in between. And that gives you a rough probabilistic estimate of like, there's around this much data. And it's that sampling is why, like, if you're trying to, you know, you ask for 2 keys and it gives you nothing because what's between there is like 2 megabytes, then it's that. But if like you're asking 2 keys and there's like, you know, 20 gigabytes between it, then you're going to get like the noise sort of drops out at that point, because especially once you're crossing entire shard boundaries, like you have a pretty reasonably good idea of sort of approximately how much data is in there.
Awesome. Okay, awesome. That's super useful. That's really good to know. Thank you.
Yeah. Have you looked at the transaction tagging stuff at all?
Not yet. Is that in terms of tagging it in terms of different tenants?
Yes, it's like it's sort of technically unhooked from tenants, so you can use it without tenants, but just sort of tagging, like I think especially in your case, like or tagging something with tenant or like, background system work versus foreground user work.
Okay, so I actually don't know enough about this. Would you mind giving me a quick overview? This sounds like
so there's a call that you can make to set on a transaction some tags. The tags are pretty limited, and I think it's like you get 16 bytes per tag, so you have to do some sort of clever tag generation scheme, and you can only get 5 tags. Some tags are manual and some tags are automatic, where the difference is that the manual ones are basically there so that you can sort of get a analysis analysis out of the system about like how much workload is associated with that tag. The automatic ones get automatic throttling applied to them. So if you have like, the point of this is so that you can have a bunch of clients all submitting transactions, you tag the transactions with the same thing, and then FTP now understands that that's actually one workload instead of just a whole bunch of independent clients. And so if it needs something to throttle, it can now look and see, oh, I have this workload that's relatively intense. Let me throttle the workload instead of just blanket throttling all clients.
Interesting. Oh, that's brilliant. Okay. And so is there a way, so I mean, obviously the big problem with background work is that you're gonna, you increase the chance of conflicts in terms of when a user kind of doing a update and, the background worker working on the same documents. Is there a way of somehow saying, if there's a conflict, if there's a chance of conflict, allow one transaction through over the other, or prefer specific transactions over the other ones, or some way of avoiding it so that if the conflict happens, it happens on the background worker side rather than the user side?
Nah, there's unfortunately not any sort of transaction reordering tricks that I know of that you can play.
Yeah. It was one of those wishful thinking. I thought I better just ask you just so I know my bases are covered.
Can't you use a transaction batch mode for that to separate like workload from the OLTP workloads and the transaction which are updating index and in the background?
The batch mode has some interesting caveats. So batch mode applies to the GRV only. Once you get a GRV, you're essentially the same as any other transaction. Batch mode has a lower limit for how much saturation or pushback needs to exist in the system for the GRV to start having its latency increased. And there's some lower rules. So in particular, like if a storage server fails, and so T-logs start accumulating data on disk for the failed storage server, until that situation kind of fixes itself, you might end up with batch priority transactions starved, because the outward signals and the metrics that exist, it's kind of hard to tell the difference between like transaction logs are having to spill excess data to disk because the storage server failed, or they're doing that because the storage server is overloaded and is behind. And if it's overloaded and behind, then starving batch workload because you actually need to decrease the amount of work in the system is like totally correct thing to do. But if it's just a storage server is failed and you're working on replacing it, then you wouldn't want to starve the batch workload, but then like there's no good signal in that particular component of the system to know the difference between those two cases. So the times that I recommend using batch is like, if you were doing some massive data migration or some like very large system load or something, where this is work that like if it got starved for a couple hours, it's fine. You just like want to use, if there's some idle excess capacity in the cluster to do this work, that's great. If there's no idle capacity and you're fine with the workload being starved for a while, that's also okay. Then that's like a great situation to use batch priority.
Right. Thank you, Alex.
Yeah.
Cool. Should we stop there?
Yeah. So thank you, everyone, and we will see you next month. Thank you.
Yeah.
Thank you, Garren, for your talk.
Pleasure.
Have a nice day.
Yeah, and thanks everyone for coming out. I really appreciate everyone listening to my talk.
Thank you.
Cool. Cheers.